In nature, things can have sex and they can pollinate each other and they can create offspring that are naturally occurring offspring. And so, like species breed with like species. In the plant world, we can, as humans, we can look around and see that there are plant families that you can actually hybridize within a plant family to get a specific trait. So let's say that you noticed that your broccoli had a really fat stem and that fat stem was really tasty. And there were, of all your broccoli plants, 20 of them had really fat stems. Well, you could collect the seeds from those and breed, you could cross-pollinate those on purpose to get fatter and fatter stems. And that's how we got kohlrabi, right? Kohlrabi is the super fat stem. Or we could notice that some buds on the brassica plant looked like little baby cabbages, and you could cross-pollinate those, and then you get your Brussels sprouts. And so we're looking at taking specific traits in plants and genetically selecting for the most tasty or for certain properties. So humans, over our whole history, have basically been genetically selecting all the time. So when we eat the fruit, we're like, oh, wow, that one's really good. And in the old days, you were traveling and semi-nomadic, and so you'd eat that fruit, and as you walked along your nomadic or semi-nomadic pathway, you would defecate, and then you would have the seeds, and that little fertilized pile would plant itself. And so basically, we moved our genetics with us as we went. Hybridizing is really a very modern art. Hybridizing's really only been since the last 150 years, less, really, that people really started to understand, 200 years, understanding how hybridizing works. Grafting is about 2,000 years old, and we could do grafting another day. We will do grafting another day, but grafting is basically selecting the genetics of a certain tree and putting it on a different rootstock in the same family. So a good example is there's a Siberian peach tree rootstock. It's very cold hardy, it's really drought tolerant. It's a really tough, great rootstock, but the fruit that it bears is really not that tasty. So you can take a little scion wood or a little piece of another tree and you can graft it onto the rootstock of that one so you can grow the fruit that you like. So most of the fruit that we eat is grafted. All apples, all pears, all plums, all peaches, all nectarines, all citrus, all avocados, all mangoes, and the list just goes on and on and on. Those are all clones of an original that we liked. Genetic modification is taking two unlike species and penetrating the cell wall and introducing genetics from another species and basically creating a new life form that never existed before. And they do it through a virus vector often. And so they use a cauliflower, the cauliflower something virus, then they take, in your lab suit in the lab with the whole thing and they inject it into the cell wall to create a new organism that would never, ever, ever occur in nature. And we don't know the long-term consequences of them. So they breed the genetically modified organisms to be resistant to a pest or to have a terminator gene, which means that the seed is sterile. So try explaining to a Guatemalan farmer, like I had to once, where they have a program called Pound for Pound. So they say, hey, we'll give you a pound of our American corn if you give us a pound of your corn. And to a farmer in Guatemala or anywhere else in the world, seed is grain, and grain is you eat, and the seed you plant. And so a percentage of it you take to eat, and a percentage of it you put in the ground. Corn is wind pollinated, so they plant the corn out. They save the seed, and the next year the plant doesn't grow. And they come and say, what did we do wrong? Did we not use enough chemicals? What did we do wrong? Because it didn't sprout. And I say, well, those seeds are sterile. And they're like, well, that doesn't make any sense. A seed grows. That's what the definition of a seed is. So in the efforts of, so under the guise of we're going to feed the growing population of the world, what they've done is come up with seeds that can't reproduce, so the farmers are forced to continue to buy more seeds year after year after year, and they also are using seeds that require more water or more fertilizer, and so they're draining their aquifers for a monoculture, for export. It just goes on and on and on. You guys mostly know about that. So genetically modified organisms are new scientific creations that would never, ever, ever, ever occur in nature by themselves, period. Even under stress of in times of genetic stress. In times of genetic stress, things that would normally not breed together might breed together. But these are things that would never, ever, ever happen.